Okay, so in today's, we're going to look at dot plots and stem and leaf plots. So they're ways of displaying data, and it's when you've got just one set of one variable, so one bit of data. So for the example here, we've got, in this first example, it says the ages in years of 13 members of a cricket team. So that age is the variable, and because we've counted, how many years they are, we would call, what type of data would that be? Categorical, numerical, and discrete or continuous. Yeah, so if just to practice, we might just pop that in. So that's numerical, and this one is discrete, because we're going to say they just counted a whole number of years, okay? So that one. So we are going to pop this in a dot plot, and it's one way to display it. So a dot plot's only used when you have not too much data, because otherwise it's sort of it gets too complicated. So we only have 13 pieces of data here, so that's okay. So you can see, I'm just going to write some notes on it, so you should do. We have a ruled number line, so you would need to have that. So a ruled number line doesn't have to start at 0. We've just started at a low number. They've done it the one before the first one. And all you have to do is obviously put a dot above your data. So we're going to go through it. So say the first one's 22. So I put a dot above 22. And 19, so on, 18. Now you want your dots to be uniform, so that, like, if you have two, the second ones are in line with each other. So say we've got the 19, I'll put the next one on there, 23, okay? So if we go through it, I'm going to quickly go through it, you end up with 2 on 18. So you can see I'm lining the second one up with all the other second ones. And we had 4 on 22, 2 on 23, 1 on 24, and 1 on 29. Okay, so we have this dot plot. So now you can describe the dot plot similar to the histogram. So see how it has these, like, they look like the towers, don't they? Yeah? So you could, if you're asked to describe the shape, they might get you to do that. With this one, it's a little bit everywhere, so I don't reckon they would ever ask you, because it's not a clear one. Everyone might start arguing, there's outliers, which part. This bit here is definitely an outlier. So, like, you can clearly see that one's it's probably an outlier. It's a well away, so we could say that's an outlier. Those first groups might be outliers too, but we'll learn about that later. So that's mainly, we're just looking at a dot plot. Okay, this is what automatically comes up on your calculator. Remember when you were doing a histogram, you put your lists in and you clicked the list on that data page to get the graph? Your first one is a dot plot. So that's where you can get it if you need it on the calculator. All right, so let's have a look at some exam questions. So the dot plot below displays the difference in travel time between morning peak and evening peak for 25 days. So what they're telling us here, when they say there's 25 days, there's 25 dots. Okay, so there was 25 days where they took the data, and like say there was the travel time between morning. So morning might have taken them 30 minutes to get to the travel, and the afternoon when they were coming back, it took 20 minutes. So they worked out the difference was 10. That's what they're sort of doing there. Okay, now it's asking for the median difference. So because this is difference in travel times, out of all this data, they want you to find the median. So remember, the median is, we talked about it, is the center, and it can be found so the median can be found, so you would have done this a few times last year, but anyway, it can be found at n plus 1 divided by 2, like, I sometimes say position or spot, whatever. Okay, so n is how many data pieces there is. So we actually know that n equals 25. That can help us, that saves us a little bit of time. And So if we put all these dots in order from smallest to largest, we'd have 25 of them. And if I do 25 plus 1 divided by 2, that ends up the 13th. So what we're saying is the 13th one from the lowest going towards the highest is the median. So what you got to do is you go and count your dots. So this dot was my first dot, wouldn't it? It would be the lowest. So I got 1, 2, 3, and then I'd go up that 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's this dot here that is the median value. So if I go down there, it's on, what's that, 1, 2, 3? Yeah? So the median is 3 minutes. So water skink eggs are hatching in a reptile house at the Millville Animal Sanctuary. The number of eggs hatching each day over the 31 period. So here, they just told me what N is. So N is 31. So we know, and we have 31 dots. Okay, so they collected data on 31 days, and the results are shown in a dot plot. So write down the range. So the range is the maximum minus the minimum, or the largest minus the smallest. So here is, if you go to the furthest dot, so 23 is our last dot, so that would be our maximum. So this is, here's maximum, and 15 is our lowest, so this is our minimum. So 23 minus 15, so our range is 8. Okay. The next one, it says we have to calculate the median. Now you could put the lists in the calculator and do all the stats and find everything, but it's not the quickest way. That's why I'm showing you how we do it manually. All right, so let's have a look again. So we're doing the same. We know that median is found at n plus 1 divided by 2 position. So we're going to say 31 plus 1 divided by 2. So that would be the 16th spot, okay? So I'm going to go and count from the lowest going towards the highest till I get to the 16th dot. So watch up here, because I'll do it in the thing. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm in that column, which is what? 19? So the median is 19. So I'm going to box my answer because I'm just writing, you only have to write 19. I'm just writing the working out so you know how I've worked that out. If you reference this, you can see it, but you just need 19 there. So I'm boxing that answer. Okay, so if you look at more than 19, we've got, so for the, for the question where they're asking us for how many are more than 19, we've got to go, we're just going to count the ones after 19. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there was 12. Write down the number of days on which 21 eggs were exactly hatched. So there was none on the 21. So we're going to say that there was 0. If you wrote the number 0, that's fine as well. Now, what we're going to need to get into a good practice now, when they say the percentage of days. So look to see what they're asking. When they're asking for the percentage, I want you to write down your general rule for percentage, which is you do the amount out of the total times 100. So if you write that, then you'll know what you're looking for. So it says the percentage of days on which more than 19. So how many total days did we have? Remember looking at your thing? How many total days did they collect the data for? 31. So we know that's 31. Now, the bit on top, the amount will be what they're asking. So, which they want to know more than 19 eggs were hatched. So we'll go back and have a look at our dot plot and count how many were more than 19. Here we said we had 12 days that were more than 19. and then we would times that by 100. Now, we also need to make sure we are checking all of this. We should be highlighting these in our exams to correct to 1 decimal place, so that when I write my answer, so I ended up with 38.7, I've done to 1 decimal place. So even if you only have 30 seconds to check your work, you can look at the highlighted correct to 1 decimal place and look at your answer and make sure you've done that. Okay, a stem and leaf is a useful way of displaying data containing up to 50 observations. So once again, stem and leafs aren't very good if you've got heaps and heaps of data. So when we say small amounts, so 50 is not huge in the world of surveying. So what it does is it breaks up the data into what we call a stem and a leaf. And the first digit is always the stem of the number. So it's only the first digit and, the first numbers are the digit. The last one is always the leaf. So, and it is another way of ordering data, because when we do this, if you look, you have like the smallest, you start with the smallest number and then you end up with the largest. So you might just write in there, that's the minimum and here's the maximum. So we could get all of those information. All right, what we have to look at, if you have a look at this, say, this stem and leaf, we're going to be looking at this one coming up. So we can then describe this data. Now, if I flick it that way, it looks like, you could either say a dot plot, or it also looks like, say I made them towers, would you agree it looks like a histogram? Yes? So we could describe the shape of this. So I might say that this looks fairly much symmetric with an outlier. Okay? So that's how we're going to be looking at describing it. We get these stem and leaf plots, so the data's there. What they'll ask you to do is describe it, because that's what we want to do. We want to say, what does the data show, what did this survey show? So here, let's have a look at this example. It says the ordered stem and leaf plot opposite shows the distribution of test marks of 23 students. So you know that n equals 23 there, and if you also want to know, because n equals 23, that means there's 23 leaves. Yeah, so all those outside, there's those many leaves. So name the shape and note if any outliers. So we just did that. We flicked it around and we could see the shape. So this shape we're going to say is symmetric. And with we'll say a possible, because we haven't tested if it's an outlier. So we'll just say a possible outlier at 60. So because they said, now the other thing I should have noted is that a stem and leaf plot should always have a key. And I don't know why this one doesn't, so we're going to put a key. So a key can have any number, so they'll just, a random number, and then they'll tell you what that means. So if I have a stem of 1-8, that means it's 18. That's what I'm going to go for. All right, it did it in the example up the top. It did show there was a key there. We can see the key here. Okay, so going back to that, so we know that. Now it's asked us to locate, I'll change pen color here, locate the center. So the center is the median. And so we're going to find the median at n plus 1 divided by 2. So we knew that n was 23. So it'll be in the 12th spot. So once again, you don't have to write all this out. I am just showing you so we know how to get it. So I'm going to go up the 12th leaf. So this is the smallest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to say 30 is the median, and that's the center. Okay, so that would be your answer. Now, the spread is the range. We could use the range or the IQR. At the moment, I'm just going to use the range. So it's the maximum minus the minimum. So the maximum value is up here, 60, and the minimum one was 15. So we've got a range of 45. Okay, and is there any outliers? Yeah, we're just going to say at 60. Have a stem and leaf plot shows the ages of people in a Tai Chi class. The median age is, so you can see they gave you a key, so you had to give the key. Now, the median we know is found at n+1 divided by 2 spot or position, whatever. So I need to know what n is. So they haven't told me for this example, so I have to count the leaves. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 leaves. Okay, so this is a good one because this one's going to cause us a little bit of, be a little bit different. So if I do the median is at 20 plus 1 divided by 2, that means I'm at the 10.5 spot. Yeah? So 10.5, that means it is in between the number between the 10th and the 11th value. Okay? So when you get one like that, so if you have even number, it's going to be in between. So if we count up our, find that where they are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 10th one was 33 and the 11th one was 34. So what is what's the middle of those numbers? What's in between that? Yeah, 33.5. So we know the median was 33.5. So that's how you do it when it's like an even number. Okay. A company that sells jeans has 20 outlets. The results of the sales at each outlet are listed below. So they told you n equals 20. That can make your life a little bit easy. What percentage? So again, I see that it's the percentage. So I'm going to write amount at a total times 100. This is to make sure I do it right. So the amount, what percentage of the outlets? So I know that's the total. I had 20 outlets. And then we want to know sold more than 50 pairs of jeans on a particular day. So I want more than 50. So 51 is 1. So we want to know how many was more. So we've got 1, 2, 3, 4. There was 5 outlets that sold more than 50. So change that to a percentage, and that we get 25%. The stem and leaf plot in figure 1 shows the distribution of the average age in years at which women first marry in 17 countries. So 17 countries, that was how many leaves we have there. And they've also given a key. Be careful because the leaf is a decimal place, okay? So what is the lowest age of a woman at first marriage? So this is the minimum. So it's 25.0. You won't get the answer unless you write 25.0. Okay, the median average of women at first marriage. So the median, remember, n+1 divided by 2. So we had 17 plus 1 divided by 2. So it's the 9th. And so we've got to count up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is 28.2. So be careful, that leaf is indicating a decimal place. Okay, the stem and leaf plot shows the distribution of mathematics test scores for a class of 23. So we've got n equals 23. For this class, the range of test scores, so range is max minus min, So I go and look. Make sure you look at the key. So the key is simply a unit there. So the max is this one, 89, and the minimum is 40. So we've got a range of 49. Okay. So now this one is a little bit, we haven't sort of talked about too much about the interquartile range. We will go more into it, but I want to do it with you anyway here. Okay, so the interquartile range, so first of all, we're going to know interquartile range is when you do the Q3. So the median is Q2, the second quarter, okay? So Q3 is the third quarter mark and Q1 is the first quarter mark. So that's what IQR range is when you get Q3 and you minus it. So we're going to try and work that out. So when you have data, and I said before, so if you split it in half, there you have your median. Okay, so which I'm going to help you out. So that's Q2. So what we know is if essentially Q3 is like the middle of the second half, yeah? So you could say the middle or of second half, or even you could say the median, and Q1 is the middle of the first half. So how we've been working out those medians, we can just do it for the first half of the data and the second. So here we said we had 23 data, okay? So that means because n equaled 23, the median was going to occur at the 12th, yeah? And that meant you have 11 numbers before it, 11 data points before, and then you have 11 data points after. If you have 11 numbers, what would, in order from lowest to highest, what would be the middle number of 11 numbers? 6. It'd be the 6th, yeah? You'd have 5 before it, 5 after. So it'd be the 6th number. And it can be the 6th that way. So what we're going to do is we count in 6 from the start. So say 1, 2, 3, 4, 5, 6. So Q1 is actually 57. And then I can just go 6 in from the end. So what I'm going to go backwards, I'm going to go 1, 2, 3, 4, 5, 6. And I see that 75 is Q3. And that's how I get that interquartile range. And like I said before, interquartile range is better because it's not affected by those outliers. And what it actually tells me, it tells me where the middle 50% is. The middle 50% range between there. And that's good because that's a majority. We can say, well, the majority, half the data is in between those. We're going to see the extremes in the other ends. That's why we'll just look at that middle bit.
Okay, sometimes we can compare two sets of data with using a stem and leaf. And what we mean by two sets, so say looking at this example here, you might have collected the heights for males and females, and so that you do this back-to-back stem and leaf plot. So the stem down the middle is the same for both sets of data, and then you have your leaves. Okay, so I just wanted to go over a back-to-back one. We have to be careful, so you could get all the separate stats for each. So say if you have a look at the women, we might see, like, first of all, you could see how many women they surveyed by counting up the leaves. So the women, there was 10 women in the thing, and then you could look over here and count the men. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there was also 10 men, but they might not be the same all the time. Like, they might have different amounts of people who were surveyed and things like that. What I want you with this one, when we talk about the shape, so if you look at the women's shape, we would say that is probably most likely it's positive skewed, maybe with an outlier. positive skewed, but we'll just say positive skewed, possible outlier. What you have to be careful with a back-to-back, a stem and leaf plot, is the one on the back, this one, because it looks to the eye, you've got to be careful when looking for the shape. If I flip this and made it like a dot plot with the stems down here, and if we measured that out, it's sort of the reverse of how your eye sees it. So I just want you to be careful, because if you actually order it from smallest to largest, smallest, so you could see this one. So we might say this one is actually negative skewed, because it has more at the towers up at the end, maybe with it, sort of. But just be careful, because sometimes it doesn't look like that to your eye. You think if it's so just be careful. It's got to be lowest to highest. All right. Let's have a look at these questions. So a back-to-back stem and leaf plot shows the number of newspapers purchased by month by men and women, and they've given a key. So what percentage of women, so they want just the women, so you have to be careful there, because when we write our formula, amount out of total times 100, the total is actually the total women. So we counted that before and we saw that was 10. So 10, and then we look at what they want. In the sample purchased at least 24 newspapers each month. So at least 24, so we've got 1, 2, 3, so that would have been 3, and then we do times the 100, so we get the 30% for that. So just be careful, because that one, they just said percentage of women, they didn't say in total, not men and women. So the developers record noise levels at 2 proposed residential sites, A and B. The results are listed in a back-to-back stem and plot. Which of the statements is true? So we need to go and find, you can see they're talking about the median of both sites and maybe the interquartile range. So you probably need to work out all of those for each, and then decide on which one of the following statements is true.